Did you know that trying to run a 20 HP motor with a 10 HP VFD can actually work? But only if you know how to do it right? Sounds crazy, but what if I told you that, in some cases, you can run a higher rated motor with a lower rated VFD without immediately damaging it? However, running a higher rated motor with an undersized VFD is not recommended under normal conditions, as it can lead to overloading, overheating, and premature failure. However, in certain cases, you can carefully configure the system to make it work under limited conditions. Here's how. Welcome back to Instrumentation Unlimited channel. In this video, we'll uncover the tricks to safely starting and running a larger motor on a smaller VFD. We'll break it down with real-world examples, step-by-step strategies, and some expert insights. Stay till the end to avoid the common mistakes that could fry your equipment. So, why doesn't a 10 HP VFD work out of the box for a 15 or 20 HP motor? The answer is simple: power and current limits. It's all the game of manipulation of power and current limits features available in a VFD. Let's check out how we can play with it. Let us assume we have a motor of 20 HP, 460 volt, 27 ampere, and a VFD of 10 HP, 460 volt, rated for 16 ampere output. Now the problem statement is, a standard 10 HP VFD having 16 ampere rated output cannot provide the 27 ampere required by the 20 HP motor. If you just connect and run it normally, it will overload and shut down. But wait, there are ways to make it work under certain conditions. Let's explore them. Now, let's get into the techniques that can actually make this setup work. But remember, this only applies when your application doesn't need full motor power. I repeat, when your motor runs on load below VFD rated currents. We have 3 VFD settings that need to be set in a VFD to run a higher size motor. You can set this way. 1. Set the maximum output current in the VFD menu at rated VFD current. 2. Increase acceleration time to reduce inrush current. 3. Enable overload protection to avoid overheating. Now, a 20 HP motor needs 27 ampere, but the VFD can only provide 16 ampere, and you have set the VFD current limit to 16 ampere. This means the motor will only draw as much power as the VFD allows, and higher acceleration time will ensure current demand to increase slowly to desired setpoint RPM. The downside of this arrangement? The motor won't reach full power, but can still operate at partial load, below the maximum VFD full load current. This is the only limitation you have to check out for a higher size motor you want to run with a lower size VFD. That higher size motor power on operating load must not exceed the full load current of VFD in any case. This you have to ensure and measure actual load current with a tongue tester before doing such an arrangement. The moment a higher size motor crosses the FLA of VFD, it will be tripped with the overload protection you set. So you have to take care of this thing, and it is the only condition to run a higher size motor with a lower size VFD. As you know, power demand reduces as the motor speed decreases, so this method for applications can be used on fan VFDs that don't require full speed. For example, a 20 HP fan motor running at 50 Hz consumes full power. But if you run it at 25 Hz, the power demand drops significantly, allowing a 10 HP VFD to handle it. This method is ideal for fans, blowers, and pumps with variable load requirements. Using a smaller VFD can be a temporary or emergency solution, but it's not ideal for long-term operation. This is the bottom line. I hope this video cleared up some myths and helped you understand when and how to make this setup work. If you found this useful, smash that like button, subscribe, and tell me in the comments, have you ever run a bigger motor with a smaller VFD? I'd love to hear your experience. Thanks for watching, and I'll see you in the next video.